All right, if you're in the world of drones, autonomous robots, or precision ag, you know the entire game boils down to one thing: accuracy. But what happens when that accuracy just disappears? Today, we're taking a look at a new RTK receiver that claims to solve some of the biggest headaches in high precision positioning. This is the Jumpstar X43 N1. Right off the bat, this little device is making three huge promises that really hit home for engineers: a signal that doesn't quit, a form factor that's almost impossibly small, and performance that could set a whole new bar. So let's dig in and see if it actually delivers. Before we get into the tech specs, let's just set the stage. In robotics, in drones, precision isn't just a nice-to-have feature, it is absolutely critical. We're talking about getting things right down to the centimeter, where any little slip-up can mean the difference between a perfect run and a total disaster. And that leads to some very familiar frustrations. Come on, we've all been there, right? You lose your RTK fix the second you get near a tall building. You're fighting all this radio noise coming from your own electronics, and you're constantly stuck in that balancing act between performance, size, and how much power the thing drains. It's a real battle. And this is exactly where the Jumpstar X43 N1 comes into the picture. It's not just another receiver off the shelf. It's been designed from the ground up to tackle those specific pain points head on. You know, just as important as the hardware is the company that's making it. This isn't from some fly-by-night startup. Jumpstart Technology has been a serious player in this space since 2010. They have a whole ecosystem of solutions, which means you're not just buying a component, you're getting a stable, long-term partner. In this industry, that kind of credibility is a really big deal. So, let's tackle that first big problem. How do you keep a solid signal lock when you're in a really, really tough environment? Yeah, this is the classic urban canyon nightmare. Your robot, your drone, it works perfectly out in an open field. But the moment it gets between buildings or under some trees, that beautiful centimeter-level accuracy just vanishes. It's incredibly frustrating and really limits where these amazing systems can actually be deployed. So how does the X43N1 solve this? Well, it pretty much comes down to one big number: 1408. That's how many channels this thing has. It's just a massive amount of signal processing horsepower packed into this tiny box. And having all those channels is what makes their all-constellation, all-frequency tracking possible. What that really means is the receiver isn't just looking for GPS. It's listening to everything, all at once: GLONASS, Galileo, all of them. By seeing more satellites across more frequencies, it can piece together a super reliable position, even when half the sky is blocked from view. Okay, so having a stable signal is one piece of the puzzle. But what about a clean signal? The next huge hurdle is radio frequency interference, or RFI, which can totally scramble your data and ruin your day. I mean, just think about all the electronics crammed onto a modern drone. You've got radios, motors, flight controllers. They're all screaming out electrical noise. And that noise can easily drown out those incredibly faint signals coming from the satellites, basically making your receiver go blind. The best way I've heard this explained is with this analogy. The X43N1 solution is basically like putting a pair of high-end, noise-canceling headphones on your positioning system. It's built to zero in on that clean satellite signal while tuning out all the garbage noise around it. And here's the tech behind that analogy. The datasheet calls out 60 decibels of narrowband anti-jamming. Now, to an engineer, that is a huge number. It means this receiver can fight off incredibly strong interference and still keep your positioning data clean, accurate, and trustworthy. Now for the trade-off that haunts every single mobile robotics project: size and weight. You can have the best performance in the world, but if the component is too big or too heavy, it's a non-starter, especially when you're running on batteries. I mean, just look at these dimensions. We're talking under 44 by 34 millimeters. This thing is small. Like really small. It makes it so much easier to design it into a tight space without having to compromise on everything else. And then there's the weight: less than 25 grams. For a component with this much power under the hood, that number is honestly just wild. So what does this actually mean for you? It's simple. Shaving off every last gram means your drone can stay in the air longer. It means your robot can carry more sensors, a bigger battery, a more valuable payload. This isn't just about a number on a spec sheet. It's a real competitive advantage. So when you put all these pieces together, the rock-solid signal, the incredible interference rejection, and this tiny, tiny form factor, you really start to see why this isn't just another small update. It's a genuine leap.
This table really nails it. Those 1408 channels, that means you lock on fast and you stay locked on. The anti-jamming, it means you can actually trust that lock in the real world. That sub 25-gram weight gives you more mission time, more payload. And all of it works together to deliver that true sub-centimeter RTK precision. Each feature is solving a very real, very frustrating problem.
You see, getting all these capabilities into one tiny, lightweight package is what makes the X43 N1 so compelling. It just erases so many of the compromises that engineers have been forced to make for years when designing these kinds of systems. And that really brings us to the final question, doesn't it? When you have a receiver this small, this robust, and this reliable, what new things suddenly become possible? How could this completely change the way you design your next drone, or robot, or precision ag system? It's definitely something worth thinking about.